Okay. Yeah, no problem, no problem. Uh, so let's start with today's session. Okay. Yeah, no problem. I just wanted to check whether my mic is working because I think between one of the classes, my mic had shown some issues. But okay, now I think everything is fine. Anyways, let's not delay much. Let's just get on with today's session. So, yeah, yes, Subhajit. Okay, I'm not sure whether I can be of help because I'm not really involved in the process. But yeah, just ask. I'll see. I'll answer with what I know. Mm-hmm. Um, Previous year questions. I'm not sure whether it is available. I mean, for me, it was actually so I had the help of the NPTL team to procure this previous year questions, the assignment questions basically. Question paper, I'm not sure. You can maybe try contact the NPTL team itself directly and see if you are able to get the questions. But yeah, any other queries? Okay. Fine. Let's get on with today's session. So today, again, we'll be continuing with the renewable source of energy. So today we'll be dealing with hydro energy, geothermal energy, and tidal energy. So we'll see what these three different energies are. We'll try to find out how energy is harvested or in what form the energy is harvested from these hydro, geothermal and tidal waves, and what are the applications advantages and disadvantages of this type of renewable energy. So we have learned in school regarding this hydrologic cycle or basically water cycle. So water from the ocean will evaporate and it goes to the atmosphere, and as the temperature decreases, it forms rain clouds where these from these rain clouds rain occurs or precipitation basically in the form of rain, and this water gets stored in the form of groundwater underground, and thus this cycle of water goes on. So this is called as hydrologic cycle. We have learned, I think, in our school days. So basically we'll be putting this cycle to use to produce hydrologic energy. So basically hydro energy, as the name itself suggests, we are trying to produce energy from the flow of water. So hydropower comes from flowing water, which is a component of the hydrologic cycle. So from this flowing water, how are we producing energy? So there are different types that we can use. So hydropower plant captures the energy of the falling water to mainly generate electricity. So electricity is the form of the energy that we procure via hydropower energy, and basically we can just use a turbine to convert the kinetic energy of the falling water into a mechanical energy, and this mechanical energy will be converted by a generator to produce the electrical energy as the output. And to achieve this, we have different methods or techniques to do that. So we can have dams, just normal or natural flow of water, or something called as tidal barrage, and basically different flow techniques of water. So water will be flowing, and this flowing water will enter the water turbine, where the kinetic energy of this flowing water is converted into mechanical energy, and this mechanical energy is then converted into electrical energy by a generator, and we finally get the electricity as the output from the flow of water. So that is basically the schematic of production of hydropower energy. So this is a very simple demonstration of how we can generate electricity using dams or reservoirs. So you have these dams here. So water will fill up to a level in this dam, and from here the water will start flowing from the dam, and this water will have kinetic energy. Basically, this kinetic energy filled water will go to the generator or powerhouse, where electricity is generated, and these are stored in these power lines. So that is basically how we use dams to produce electricity or electric energy from the flow of water. And some of the advantages and disadvantages of hydropower is that, firstly, because it is a renewable source of energy, there are no emissions. So virtually no carbon emissions, or nitrogen oxides or sulfur oxide emissions, no kind of emissions. And yeah, it is water is basically a renewable, considered as a renewable source. So hydropower mode of generating electricity is considered a renewable source of energy with high conversion rate, with greater than 80% conversion efficiency. And it is dispatchable with storage capacity. It is usable for base load peaking and pumped storage applications, various applications, and it is the main advantage is that it is scalable. So you can generate energy from anywhere from 10 kilowatts to up to 20,000 megawatts. And once the system is built, the operating cost and maintenance costs are very low. And usually these projects have a long lifetimes of decades, or maybe even centuries. Like long lifetimes. But some of the disadvantages of hydropower is that it frequently involves impoundment of large amounts of water with loss of habitat due to land inundation. So this is a very huge drawback, because in order to construct a dam, or basically using dam, you are trying to build a reservoir of water. Okay. Yeah. So you're trying to build a reservoir of water, and there a lot of the habitat, or if there are people that are living nearby the river, they'll have to be displaced, because the reservoir will be holding up huge amounts of water, and there will be loss of habitat around the construction of the dam and the water reservoir. So all these things are a huge disadvantage of hydropower electricity. And yeah, it is heavily dependent on the water levels, or in other terms, it is heavily dependent on the weather, mainly rainfall. So because of this, the electricity output that we get from these dam based or water based power generation systems are not constant. The output will be variable. And impacts of on river flows and aquatic ecology, including fish migration and oxygen depletion. So because we are stopping the river flow at a point and using a dam or a barrage, we are actually having this generation or construction of dam actually has an impact on the natural flow of river, and along with it the natural cycle of aquatic ecology, mainly the migration of aquatic life, migration of fish, and so on. And yeah, again, social impacts of displacing indigenous people. I explained it in the first point. And health impacts in developing countries. High initial cost. So constructing a dam is not a child's play. It is very time consuming. Long lead in time in construction of large projects. So it is very time consuming, as well as it costs a lot of money to be built in the first place. So these are some of the disadvantages of hydropower. So to hydro generate or to convert this kinetic energy into the mechanical energy and consequently into electric energy, turbines are the most important in the powerhouse. So water turbine is a rotary machine that takes energy from moving water, and flowing water is directed onto the blades of a turbine runner, creating a force on the blades. So the kinetic energy of the flowing water creates a force on the blades, or basically is converted into mechanical energy. And since the runner is spinning, the force acts through a distance, and this way the energy is transferred from the water flow to the turbine. And then the turbine turns a metal shaft in an electric generator which produces electricity. Or in other words, the mechanical energy that is obtained from by the turbine will be converted into electricity using the electric generator. So there are different types of turbines, basically hydro turbines. So you can have impulse turbine and reaction turbine. And in the impulse turbine itself, you have Pelton turbine, turbo turbine, cross flow turbine. And in reaction turbine, you have Francis turbines and axial flow turbines, mainly propeller, semi Kaplan, and Kaplan turbines. So from the different types of turbines that we have, how do we select the turbine that we require for our needs of generating electricity? So we can use this plot in order to determine which will be the most efficient turbine for a given flow rate and head. So we have a plot basically between the head and flow of water, and we also have different lines which basically represents the energy that can be generated from the turbine. So for example, let's take cross flow. So this pink border that we are seeing here. So if the required flow rate or the operating flow rate is less than 10, and the head is also less than 100 meter, and the power that we want to generate is less than 1 megawatt, then cross flow turbines can be used. So based on this plot, we can determine what kind of turbine is the best option for our requirement. So after hydropower, we move to geothermal energy. So the this part of lecture basically went through what geothermal energy is and how it is a source of renewable energy, and various application routes of geothermal energy, the mechanism of conversion of geothermal energy to electricity, and different types of electricity production plants using geothermal energy. And the lectures also focused on various advantages and disadvantages of geothermal energy, as well as the scenario in worldwide as well as India. So geothermal energy as a renewable energy source. So geothermal energy is a thermal energy generated and stored in the earth. The geothermal energy of Earth's crust originates from the original formation of the planet and from radioactive decay of materials. So basically, this is basically the cross section of the Earth. So if we take Earth like this, so we have crust on the top, then below the crust we have mantle, and inside the mantle we have the core. So these are basically the three different ranges that are found in the Earth, and usually this mantle and core will be of high temperature, and even this core can be as high as thousands of degrees Celsius, because it is in a molten state, this core. So basically all this heat is present inside the earth's crust. So yeah, you can see the temperature gradient also here. So if we go below 2000 kilometers from the earth's surface, you have the temperature will start increasing. So at 4000 kilometers, the temperature can reach up to 4000 degrees, and below 6400 kilometers, we have the temperature 5000 degrees and above. So all this heat energy can be obtained and converted into um, yeah, into the required form of energy. Okay. The geothermal gradient, which is the difference in temperature between the core of the planet, may reach over 4000 degrees, and its surface drives a continuous conduction of thermal energy in the form of heat from the core to the surface. This high temperature and pressure in Earth's interior cause some rocks to melt and solid mantle to behave plastically, resulting in portions of the mantle convecting upward since it is lighter than the surrounding rock. So basically, because of this high temperature, a part of this core and mantle will be in a molten state, and because this molten state has lesser density compared to a solid rock, this molten state has the tendency to convect upside. So this heat can be used by us to produce energy. Basically, that is basically the concept of geothermal energy. So the rock and water that is that is present in the Earth's crust is heated because of this convection of this molten mantle, which has temperatures of very high temperatures basically. So because this temperature is getting convected towards the Earth's crust, the rocks and water that are present in the Earth's crust gets heated, and sometimes can get heated up to even 370 degrees Celsius. So this heat is what we are utilizing to produce different forms of energy via geothermal energy. So the main application routes of geothermal energy are basically to produce heat and electricity. So you can directly utilize geothermal energy or indirectly utilize geothermal energy. Direct utilization are basically heat-based application. So for example, providing heat for buildings, hot springs sometimes used as spas, and heating water at fish farms, providing heat to industrial processes, and even providing heat in order to raise plants, especially in greenhouse gases. And then the indirect exploitation of geothermal energy is the electricity. So we can convert this geothermal energy to electricity, and that is the indirect use of geothermal energy. So how can we produce electricity from geothermal energy indirectly? So this picture shows a brief schematic actually. So let's say we have a water reservoir, and below this water reservoir we have high temperature inside the surface. So what we can do is we pass water towards this high temperature region. So water will pass like this. Let's say we have this part is called as injection, and then this part of this is called collection. So, oh, sorry. So water is injected into the surface where the temperature is very high, and because the temperature is very high, whatever water is passed will be converted into steam. This steam can then be collected back upwards and then passed into a turbine, which can generate electricity. So basically, what we are doing is we are using this heat due to in the form of geothermal energy. We are heating the water and converting the water into steam, and this steam is then passed into a steam turbine to generate electricity. So that is basically how we produce electricity indirectly by using geothermal energy. So what are the advantages and disadvantages of geothermal energy? So some of the advantages is that it is renewable and sustainable, and because it is renewable, emissions are very low or negligible. It is cost effective because the heat is already there under the earth's surface. We don't have to build a lot of construction basically to harvest this energy. And the supply of this energy is constant. It is environmental friendly. The footprint is small, so whatever impact that this production of energy from geothermal energy has is very less. So the footprint is very small, low noise, low maintenance, and huge potential to harvest huge amounts of energy. And job creation reduces our dependency on fossil fuels and increases the energy security. But some of the disadvantages is that although the advantages of geothermal energy greatly dominate over the disadvantages, geothermal energy still has its drawbacks, which are mentioned below. So some of the disadvantages are the geographical limitations. So not all the places. Please explain the conflict in environmental impacts. Right. Okay. Yeah, I'll come to that. So large investments are needed and environmental impacts. So basically, what happens is, if left unchecked, right. So environmental friendly in due to the fact that we are not burning any carbon dioxide, NOx, etc. But again, environmental impacts. What I can understand is that for example, let's take hot springs. It is said that this water can be heated up to even greater than 370 degrees Celsius. Or basically, what happens is it gets converted as steam or water vapor, right? And you know what water vapor actually is? It is actually a greenhouse gas. So water vapor actually contributes slightly to greenhouse effect. So what I can understand is that this environmental impact basically represents this impact of water vapor. So at least and to my understanding, that is what I am able to understand from this. And yeah, so sustainability concerns and seismic instability, because we are utilizing something that comes from the below the earth's surface, so seismic instability can also be a concern. But yes, this environmental impacts is something that we'll probably need to refer a bit into the lectures by Professor Mandal. I didn't go through it in detail, but I think you can also check what this environmental impact is as a disadvantage. But to my understanding, this is one concern that we usually have with geothermal energy. Is that okay? Okay. So that's it about geothermal energy. And then the lectures moved towards tidal energy. So tidals and waves basically. So what is tidal energy or a wave energy? Let us see. Waves and tides as a source of renewable energy. So waves are created by energy that is passing through water, causing it to move in a circular motion. The waves then transmit energy, not water, but energy across the ocean, and if it is not obstructed by anything, they have a potential to travel across an entire basin. And waves are most commonly caused by winds. So you have wind driven waves or surface waves, which are basically created by the friction between the wind and the water at the surface of the ocean. So as the wind blows, the surface of the ocean, also, it causes friction between the wind as well as the surface of the ocean, and this causes continual disturbance to create a wave crest. So these are the waves that are found globally across the open ocean and along the coast. So yeah, so these are basically normal, wind-driven waves or surface waves. But in extreme cases of especially extreme weathers, we can have hazardous waves, which can be caused by something like a hurricane, or we can even have extremely hazardous waves called as tsunamis, caused by underwater disturbance, especially in the tectonic plates, which displaces large amounts of water quickly due to either earthquakes, landslides, or volcanic eruptions. And apart from the wind friction, the gravitational pull of the sun and moon also causes waves. So these waves are tides, or in other words, tidal waves. So how do we generate electricity or energy from these tidal waves? The kinetic energy of the waves and tides can be converted into electricity. So basically, that is how tidal energy is put to use in order to convert electricity. So we convert the kinetic energy of the waves and tides into electricity. So in order to produce wave energy, we have different devices. So shoreline devices are basically one that are found in the coastline. They can be both in and out of the water. And you have something called as nearshore devices, which are usually at 20-meter deep in water. And then you have offshore devices, which are more than 30-meter in depth from the surface. So these are just some of the devices that is used to detect to produce tidal energy from the waves and tides. So tides, you have something called as tidal cycle. So tides are periodic rise and fall of sea surface or waves occurring once or twice in a day, driven by gravitational attraction by the sun and the moon and the earth's rotation. So let's say the moon is here. When the waves or the beach or our surface is 90-degree with alignment with the moon, we have something called as low tide. And when it is in line with the moon, we have something called as high tide. So both this surface and this surface will have high tide, and at that same time the perpendicular surfaces, which are 90-degree from the moon's alignment, will have low tides. So this is the tidal cycle. And we even have an equation to find how much number of uh, tidal waves that are generated in a year. So we'll look into this equation basically during our numerical assignment. But yes, so this is basically the tidal cycle. So when the earth rotates again, this part can come top, and the high tide part can be low tide part. So this kind of cycle happens for the tidal waves basically. So tidal energy is a form of hydropower that transforms the energy obtained from tides into useful forms of power, mainly electricity. So a tidal generator converts the energy of the tidal flows, basically the kinetic energy of the tidal flows, into electricity. And greater tidal variation and higher tidal current velocities can dramatically increase the potential of a site for tidal energy generation. So again, basically the principle is pretty much same as what we learned from hydro energy. The kinetic energy of the tides are basically converted into electricity, right? Yeah. So during high tide, the water flows into the dam, and during low tide, water flows out, resulting in turning of the turbine. Therefore, tidal generators are designed to produce power when the rotor blades are turning in either direction. And because the Earth's tides are ultimately due to gravitational interaction between the moon and the sun and the Earth's rotation, tidal power is practically inexhaustible. Or in other words, it can be classified as renewable energy source. Because the sun, moon, and the earth are going to exist for billions of years from now, and the earth will keep rotating, and because of these actions, the gravitational pull between the sun, moon, and the earth's rotation will exist for billions of years to come. So basically that is why it is practically inexhaustible, and it is classified as a renewable energy source. So again, to harvest the kinetic energy and convert it into electrical energy for tidal waves, you have something called as tidal turbines. So tidal turbines use similar technology to wind turbines, although their blades are much shorter and stronger. So yeah, you can actually see the tidal turbines. These actually represents the wind turbines that we learned in the wind energy generation. So the tidal turbines also look pretty similar to a wind turbine, but they have much shorter and stronger blades. The water current turns the blades or the turns the turbines or the blades of the turbines, which in turn activate a generator that produces electricity. So water flow, let's say the water, because of the water flow, this turbine, starts rotating, and this rotational energy, this part is connected to a generator, which converts this mechanical energy or rotational energy into electricity. So basically this works as how a wind turbine works, but instead of keeping it in the open, these are kept in the ocean or underwater. The system works best when there are very strong tidal zones. So, for example, Norwegian and British coastlines have very strong tidal zones. So, in these places, there is a huge potential to harvest these tidal energy. Upfront cost of these tidal stream systems is also very high, and also installation and maintenance is difficult. So, this is a disadvantage actually of tidal turbines. So, initial cost and the maintenance cost of these tidal turbines are pretty high. But this is cheaper and has less environmental impact than another tidal system which uses barrages. So that is the advantage of using turbine over other systems like, let's say, a barrage, water barrage. Tidal power is not yet widely used around the world, although it has a potential for future electricity generation. Among the sources of renewable energy, tidal power has relatively high cost and limited availability of sites with sufficiently high tidal ranges or current velocities. Many recent technological developments and improvements, both in design, such as dynamic tidal power, tidal lagoons, and turbine technology, indicate that the total availability of tidal power may be much higher than previously assumed. So, Siwa Lake Tidal Power Station in South Korea is the world's largest tidal power installation that is present. Okay. So yeah, so these were basically the topics that Professor Mandal was teaching in his lectures for this week. So basically, just I just ran through the hydro energy, geothermal energy, and tidal energy. Let us try to solve some previous year assignment questions. What is the meaning of last sentence? Mean operating tidal range is 5.6 with the spring tidal range of 7.8. So tidal range is basic. If I remember correctly, it is the height of the tide. So the height of tide is basically average height is 5.6 meter, and spring tidal height is 7.8. So I'm guessing it is during the spring season, right? Let's move on with the assignment questions. Okay, so first question: in hydropower plants, energy is produced by using any guesses? So the energy, so both A and B is the right answer here. Yes, exactly. Because when we are using dam, so the water at the highest point will have some potential energy, and when it starts flowing into the turbine, this also will have kinetic energy. So both potential energy as well as kinetic energy of the water plays a role in producing energy through hydropower plants. So both A and B is the right answer. Which of the following is the example of a reaction turbine? So we saw the different types of turbine that are used for hydropower. So both Kaplan turbine as well as Francis turbine are part of reaction turbine. So both A and B again is the right answer. What causes some rock to melt and solid mantle to behave plastically in Earth's interior? C. High temperature and high pressure. Yes. Which of the following statement is false for tidal energy? So surface waves are created by the friction between wind and surface. So this sentence is actually true. Kinetic energy of waves and tides cannot be converted into usable form of energy. So what about this? Is it true or false? Yes. So this is the false sentence here. So let's just go through the other sentences also. Hazardous waves are called tsunamis, can be caused by underwater disturbances. This is true. And the gravitational pull of the sun and moon also causes waves. This is also true. So option B is the false statement here. Which of the following properties corresponds to shoreline devices? So where are these shoreline devices found? Are they found, you know, deep inside the water, or in coastlines? So when it comes to shoreline devices, we saw that these shoreline devices can both be in and out of water. So looking at these options, They are situated at 20 meter water depth is not right because that is yes. So they are also not that 30-meter deep in water. They do not require significant coastal earthworks. We are not sure about this, but they are fixed to or embedded in the shoreline. So that is one thing we are sure of. So answer is option D. They are fixed to or embedded in the shoreline. Tidal turbines use similar technologies to wind turbines, although their blades are much dash and dash. Yes, shorter and stronger. The world's largest tidal power installation is where? Yeah, it is located in South Korea, which is the Siwa Lake tidal power station in South Korea. Right? Okay. So this is a numerical question. Determine the quantity of heat generated due to braking to stop a goods train consisting of 20 wagons and traveling at a speed of 36 km per hour. The average weight of each wagon is 10 ton force. Calculate the time required to produce equivalent amount of electric energy by a small tidal power plant of 75 kilowatt capacity. So, okay. So how do we do this? Let's see. So let's see, are there any hints? Okay. So this is the hint that I can give you. 1 kilowatt hour is 367,098 kilogram force meter per minute or whatever. Right. So basically they have said that there are 20 wagons and each wagon has a weight of 10 ton force, or this 10 ton force can be written as 10,000 kilogram force. Okay, so this 10,000 kilogram force is basically 10 ton force. So calculate, so first we have to determine the quantity of heat that is generated due to braking to stop goods train. Okay, so actually this part is not given in the options. So let us not bother with this for now. What we need to find is basically to calculate the time required to produce equivalent amount of electric energy by a small tidal power plant. So because this wagons, so let's say we have 20 wagons like this, these are moving with 10 ton force for each wagons and we are applying brake here. So this will produce some energy, basically kinetic energy. We want to calculate the time required by a plant which is rated 75 kilowatt, and we want to find how much time it requires for that 75 kilowatt plant to produce the same kinetic energy as braking this 20 wagons at a time traveling at a speed of 36 kilometer per hour. So how do we do that? We first calculate this kinetic energy. So kinetic energy can be basically calculated by half m v square, where m is the mass of the wagon, v is the velocity of the wagon. So let us try to do this. Half m. So this is basically weight. not mass. So what? So how do we find mass? Mass will be weight by gravitational force, right? So half into 10,000 kilogram force divided by 9.81 meter per second square. So this is M. So this is for one wagon. So how many wagons are there in total? 20. So this into 20. So this is M, and V square is 36 kilometer per hour. 36 kilometer per hour. Okay, let us sorry. Okay. Right. So we are basically finding the kinetic energy of the train or the goods. Yeah. So kinetic energy will be half into 10,000 kilogram force into 20 divided by 9.81 meter per second square into, so we have 36 kilometer per hour, right? So if we look at the other units, so this is in meter per second. So we also want this 36 kilometer per hour to be converted into meter per second. So if we convert this 36 kilometer per hour into meter second, it will be 10 meter per second. So do you know how to convert this kilometer per hour into meter per second? Okay, good. So if you apply that conversion, we'll get 10 meter per second. So half m v square. So 10 meter per second square. Okay. So if we do this, just take a calculator and try to do this. So we'll get approximately 1019,367. Not megajoule actually. This is kilogram force. So the unit is slightly different here. Kilogram force, and so meter per second square will get cancelled here, and we'll have a meter also. So this is not megajoules. Okay, so be careful with the unit. So this is kilogram force and meter. So in the last slide we had this hint, 1 kilowatt is 367098 kilogram force meter. So we want to convert this into kilowatt hour. So how do we do that? 1019367 divided by, yeah, this is actually a standard conversion actually. So um, how we arrived at this, I'll have to look into the derivation of this, but this is a standard conversion that was given in the lectures, so we can use that actually. So 367098. So 1019367 divided by 367098. So if we do this, we'll get something like 2.78 kilowatt hour. Okay, so we have the kinetic energy here. So the electric energy rating of the power plant that they have mentioned is what? 75 kilowatt. So how do we find the time required for this producing the 75 kilowatt? How do we find the time required by the 75 kilowatt plant to produce this 2.78 kilowatt energy? We just divide these two. So time required will be 2.78 kilowatt hour by 75 kilowatt. So this kilowatt and kilowatt will get cancelled, and this will be 2.78 by 75 hours. So let us again take the calculator and do it. 2.78 divided by 75. So this will be approximately 0. Yes, 0.037 hours, or this is 2.22 minutes. And the answer is also 2.22 minutes. Good. Okay. So fine, right, with this question? Okay. Let's move on to the next question. The tidal range of a bay could approach 15 meter in extremity. About 100 billion tons of water flows into and out of the bay in one cycle. Calculate the total potential energy of the bay in this extreme case in 1 year by using bidirectional turbines. Gravity acceleration is 9.8 meter per second square. So to find this, we have been given these hint basically. So as I said, we during the lecture we have an equation to find the number of cycles per year, tidal cycles per year. So this is the equation for that. Number of times the tide drives the turbine, that will be 2 into the number of tidal cycles, and the total potential energy from the tidal cycle, or the total tidal energy per year, we can calculate as mgh into n by 2. Right. So we'll just go with this same order. First, let us try to find the number of cycles, and that will be 24 hours into 365 days divided by 12.4 hours. So this will be somewhere around 706.5 is the cycle, tide cycle. And the number of times for the tide to drive the turbine will be 2 into this number. So N turbine will be 2 into 706.5 into 70. This will be 1413. So now the potential energy is basically N by 2 into mgh, where m is the mass of water, g is the gravitational force, h is the tidal range. And n is the number of times the turbine is driven. So just have to substitute everything here. So n by 2 1413 by 2 into m. So 100 billion tons. So 100 into 10 raised to, how much is a ton? 10 raised to 3. We are using everything in SI units, right? So this should be in kilogram into billion. So 1 billion is how much? 5, 6, 7, 8, 9 into 10 raised to 9. This much kilogram of water into height. And this height is given as what? 15 meter. And yeah, we forgot gravity. So that will be 9.8 meter per second square. So just do all these things. Let us see how much we get. Okay. So this is actually to 15 meter. So did you get the answer? Okay, fine. I'll do it then. So if we do this multiplication actually, just a second. Okay. So if we do this multiplication, we'll get something like 1.08 into 10 raised to 17 kilogram force meter. Okay. So we have to convert this kilogram force meter into kilowatt hour. So we learned how to do that here. We just have to divide what we get by 367098. So we do that here. So this divided by 36, I'll have to insert one page. Yeah, okay. So the potential energy we got as 1.08 into 10 raised to 17 kilogram force meter, and if we divide this by 367098, we'll get potential energy somewhere as 2.9 into 10 raised to 12 kilowatt hour. Right. So the right answer here, so 2.9 into 10 raised to 12, yeah, there is one option, 2.876 into 10 raised to 12. So we'll get that as our answer. Right. So basically, just this is just P potential energy is calculated as mgh. and we are just applying everything and converting the unit from kilogram force meter to um, you know kilowatt hour. That's it. Right. If it's clear, let's move on to the last question. If the tidal range at a particular place is 10 meter, calculate the potential energy content of the water in the basin at high tide if the tidal power plant has a surface area of 10 kilometer square. Assume the density of water to be 1025.18 kilogram per meter cube. So here again we need to find the potential energy of the uh, tidal power plant of the water, sorry, potential content of the water in the basin at high tide. So potential energy is given as mgh, right? But here we need to do some modifications. So we can derive this formula half a rho into g into h square. How we will do that? Let us see. So let us take a cube like this, okay, with different dimensions and so on. So basically this m is the mass, right? And this mass can be written as density, which is rho into volume, right? V. And this volume can be written as area A into height h. So if we have a cube like this and let's say this surface area is A and this height is h, then volume will be A into h. And mass, and let's say the density of this is rho, then mass will be rho into A into h, right? Yeah, so basically that's what we do here. We substitute this m as rho A h. Yeah, this is into n. So since nothing is given about the tidal cycle, we just take this n by 2, sorry, this n as 1. So m is equal to rho A h. Just substitute it here. Pe is equal to n by 2 mgh, or this is 1 by 2 m is rho A h into g h. This will be half a rho g h square. So this is the potential energy of the water in the basin. So just substitute everything here. Pe will be half into rho. Density of water is given as 1025.18 into A. Area is given as 10 kilometer per meter square. Yeah, oh, sorry. Yeah. So this is kilogram per meter cube, and this is in kilometer square. We want to convert this kilometer square into meter square, right? So 1 kilometer is 1000 meters. So 1 kilometer square will be 1000 square, or this will be into 10 raised to 6 meter square. So that is the area. And then we have we have area, we have rho. G, that is 9.81, and h square height, which is given as 10 meter. So this will be 10 square meter square. So just do this mathematical operation here. Let's take a calculator and do it. So we'll get something like 5.028 into 10 raised to 3, 6, 9, 12, 12 joules, right? So if you look at the option A is giving us a very close value to what we got, 5.027 into 10 raised to 12 joules. So that is our potential energy content of the water that is inside the basin if the high tide at the high tide, right? Were you able to follow, Subhrajit? So basically what we did here was just convert this mgh formula into by using density rho, area A, and height h. So we just did some manual conversion of this formula, and we got this potential energy formula as half A rho g h square. And we have the data for all this A, rho, G, and H. We just applied that values and calculated the potential energy. So basically that's what we did here. Is this fine? Okay. If there are no doubts, then I guess go to next page. Okay. Yeah, so yeah. Right. If there are no doubts, then I guess we'll stop here for now. So yeah, today we just basically looked into the remaining part of the renewable energy, which are tidal energy, hydro energy, and geothermal energy. So I think we have one more week of lectures remaining, and yeah, let's meet next Sunday, same time. Thank you for joining, and yeah, I hope to see you next Sunday.